Hello, my dear students. Assalamu alaikum. I think you all are staying at home and you all are fine. I am also fine. I am ABM Moinul Islam, Associate Professor, Department of Mathematics, Rajug Uttara Model College. Today, I will discuss for the student of class 9 English version, and today I will discuss on chapter 2 from Higher Maths. The name of this chapter is Algebraic Expression. So at first we want to know what is algebraic expression. So here you can see some examples. Suppose first one is 2x. Here 2x is the product of 2 is constant and x is variable. So product of variable and constant. And later I will discuss what is variable. And in second example, you can see that there are two terms, and which are added by which are joined by plus sign. And in third example, there are four terms and which are joined by plus or minus sign. These all are algebraic expressions. So now we want to see that what is the definition of algebraic expression. When one or more numbers and symbols representing numbers are combined meaningfully by any one sign or more than one of plus, then minus, multiply, divide, or power or rational sign, a new symbol representing numbers is created. It is called an algebraic expression. Now we want to know what is variable, constant, and polynomial. So at first we can see that variable. So variable is that if the value of a symbol is more than one, then that is called variable, and the set of all values of the symbol is called the domain of that variable. That is, you can see that if such a symbol denotes any unscheduled element of the number set consisting of more than one elements, just what I said earlier, that is the value of a variable is more than one element, and we call the symbol a variable, and the set is called the domain. In any discussion, a variable can take any value from its domain. Then constant, the value of constant is fixed. That is, if the symbol denotes a definite number, it is called a constant. The value of a constant remain fixed all through. That is, the value of constant is not it cannot be changed. It is fixed. Now we want to see what is polynomial. A polynomial is a special type of algebraic expression. In a polynomial, there are one or more terms, and each term is a product of a constant and a non-negative integral power of one or more variable. So it will be clear after showing these examples. You can see that there are three examples. First one is ax plus b. Here you can see that first term is the product of constant and variable. Here x, y, these are variable. And here the power of variable must be non-negative. Okay, that means 0 or positive integer, 0 or positive integer, and the power cannot be fraction or negative. That is, I want to tell again, the polynomial is a special type of algebraic expression. In a polynomial, there are one or more terms. You can see that in second example there are three terms. First example there are two terms, that is more than one terms, and in third example there are three terms. So more than one or more terms, and each term in a product of a constant and a non-negative integral power of one or more variable. In third example, there are two variables x and y, and its power is non-negative integral. that is only positive, and non-integral means it cannot be fraction, only positive integer. So we just understand that the power in case of polynomial will be non-negative and not fraction, only integer. And now we want to know about the polynomial of one, two, or three variables. So at first here you can see that the polynomial of one variable. Here you can see that four examples of polynomial of one variables. First one is a, and this is polynomial of one variable x, so it is denoted by p of x, p for polynomial. And here the power of x is 0, so it is x free. Into it is also a polynomial of one variable x, so this polynomial is also denoted by p of x, and here x is variable and a and b are constant. In 3, it is also a polynomial of one variable x, and here a, b, c are constant. And in example number 4, this is also a polynomial of one variable x, and here a, b, c, d, these all are constant. Generally, the term of a polynomial of the variable x have the form c into x to the power p, where c is constant and p is non-negative integer. Earlier I said that the power of a polynomial must be non-negative integer. Non-negative means it can be 0 or positive, and integer means no fraction, that is it can be 1, 2, 3, 4, 5, 6 like this. Now c is called the coefficient of x to the power p in the term c into x to the power p, and p is called the degree of the term. Such an example, this term is bx square, so here constant is b, and here the degree of this term is 2. Now the largest of the degree of the terms appearing in a polynomial is called the degree of the polynomial. That means suppose in example number 4, the degree of this term is 3, here is 2, the degree of this term is 1 and it's 0. So here largest degree is 3, so the degree of this polynomial is 3. Now the term having the largest degree is called leading term, and the coefficient of this leading term having the largest degree is called the leading coefficient. Suppose in this example the largest degree is 3, so leading term is a x cube and the leading coefficient is a. Now the term with degree 0, that is the term independent of variable x, is called the constant term. That is in number 4, here you can see that this term is independent of x, so this is called constant of this polynomial. Now for an example, you can see that a polynomial p of x is equal to 2x to the power 6 minus 3x to the power 5 minus x to the power 4 plus 2x minus 5. It is a polynomial of one variable x, and now you try to understand what is degree of this polynomial. The largest degree is 6, so this 6 is called the degree of this polynomial. Then leading term, its leading term is 2 into x to the power 6, because the term containing the maximum power is called leading term. So this is leading term, and leading coefficient is 2. The leading term, the coefficient of leading term is called leading coefficient, so it is 2, and here constant is minus 5. Now we want to know that polynomial, what is polynomial of two variables. You can see that there are three examples. In one, the polynomial is 2x plus 3y minus 1. It is a polynomial of two variable x and y. So it is denoted by p of xy, p for polynomial, and there are two variables, so that is p of xy. And you can see that example number 2 and example number 3, these two are also the polynomial of two variables x and y. So also they are denoted by P of xy. The term of such polynomials have the form c into x to the power p y to the power q, where c is a definite number, that is constant, and p and q are non-negative integer. Again, these two powers must be non-negative integers. C is called the coefficient of x to the power p y to the power p in the term c into x to the power p y to the power p, and the degree of this term is p plus q. Look at here. Here the degree of any term is the sum of the power of all variables. Here x and y are variable, so their power are p and q. So degree of this term is p plus q. The largest of the degrees of the term appearing in a polynomial is called the degree of the polynomial. So suppose in 1, here the degree is 3, here also the degree is 3, so here maximum power is 3, so degree of this polynomial is 3. Now southern example, here p of xy is equal to, that is, you can see that this is a polynomial, and first question is what is the degree of this polynomial. Here the degree of this term is power 3 plus 1 is equal to 4, that is the degree of this term is 4. The degree of this term is 3 and this term is 2. Its degree is also 2, it's 1, and its degree is 0. So here the largest degree is 4. So the degree of this polynomial is 4, leading term. So therefore maximum degree is at here. So therefore this is leading term, and leading coefficient is the coefficient of the variable, that is 8. 8 is the leading coefficient, and its constant is -3. Now we want to see that what is polynomial of 3 variables. You can see that there are two examples. In both examples there are 3 variables, x, y, and z. So these two are the polynomial of 3 variables, x, y, and z. Similarly, the terms of such polynomials have the form c into x to the power p, y to the power q, and z to the power r, where c is constant, it is definite number, and p, q, r are non-negative integers. Here c is called the coefficient of this variable, that is in the term c x to the power p, y to the power q, z to the power r, and the degree of this term is again the sum of power of all variables, that is p plus q plus r. This is the degree of this term. The largest of the degree of the term appearing in a polynomial is called the degree of the polynomial. So here certain example in 2, here maximum degree is 3, so its degree of this polynomial is 3. In first term here degree is 5, 3 plus 1 plus 1 5, here the degree is 3, and here 2, so here the maximum degree is 5, so degree of this polynomial is 5. For example, the polynomial p of x comma y comma z is x cube plus y cube plus z cube minus 3xyz has degree 3. It is very important. A polynomial of the variable x is usually arranged in descending order of the degrees of x, that is the leading term appearing at first and the constant term appearing at last. This arrangement of the polynomial is called the standard form. Arthat, that is if the polynomial of variable x, if we arrange this at the descending order of its power, then it is called standard form. Now write down the homework about the discussion. Here you can see that question number 1, express the following polynomial as a polynomial of the variable x in its standard form. Earlier I said that standard form is the arrangement of the variable in the descending order. So Here variable is x, so its maximum power will be at first. So this term will be at first, then x cube, and then x square, and at last x. This. And also find its degree, leading coefficient, and a constant term. Then homework number 2, express the following polynomial as a polynomial of variable y. Here you will arrange this as a polynomial of y. So the power of y will be given priority here. In this standard form you will arrange, and also find its degree, leading coefficient, and constant term. Now we go for next slide. Now we want to know what is a remainder theorem. It's very important. Look at here what is remainder theorem. If p of x is a polynomial of positive degree and p of x is divided by x minus a, where a is any definite number, then remainder will be p of a. Just we will prove this now. This is called remainder theorem. Again I want to say, if p of x is divided by x minus a, then remainder will be p of a. This is called remainder theorem. Now we will prove this. If we divide p of x by x minus a, then at first we consider the remainder is r and quotient is q of x. Then by the law of division we know p of x is dividend. This is dividend. We know the formula, dividend is equal to divisor into quotient. Here we divide by x minus a, so x minus a is divisor, q of x is quotient, and then plus r means remainder. So this is the formula of law of division. Then by the law of division, this is the formula. Putting x equal to a, we get, here we want to put x equal to a, so instead of x we put a here. And if here x is equal to a, then you can see that a minus a, it becomes 0. A minus a, it becomes 0, and it is a, so it becomes q of a, and at last plus r. So finally it becomes r. So we consider r as remainder. So finally we get p of a is equal to r. Therefore the remainder of p of x upon division by x minus a is p of a. So it is very important formula. If p of x is divided by x minus a, then remainder is in your mind you will consider this is equal to 0, then x equal to what? X equal to a. If x equal to a, then this p of a is the remainder. Again, certain example, if p of x is divided by x plus 2, then remainder will be p of minus 2. If we divide this by x minus 1, so if we consider x minus 1 is equal to 0, then x equal to 1, and then remainder will be p of 1, like this. So this is very important remainder theorem. Now we go for next slide. Now it is also another important theorem, factor theorem. If p of x is a polynomial of positive degree and if p of a is equal to 0, then x minus a is a factor of p of x. Here p of a was remainder. Earlier we know that. Okay. If p of x is divided by x minus a, then remainder is p of a. So here if remainder is equal to 0, then x minus a will be a factor of p of x. Now its proof. According to the remainder theorem, if the polynomial p of x is divided by x minus a, then remainder is p of a. Just earlier we know it. We learned it. Here p of is equal to 0. That means remainder is equal to 0. And if remainder is 0, this means the polynomial p of x is divisible by x minus a. If remainder is 0, that means dividend is equal to divisor into quotient. What does it mean? It means that here divisor and quotient both are the factor of dividend. That is, x minus is a factor of the polynomial p of x. Now we want to know that converse of factors theorem. It is just opposite. If x minus a is a factor of the polynomial p of x, then p of a is equal to 0. Now proof of this formula or theorem. Since x minus is a factor of p of x, there exists a polynomial q of x, that is p of x equal to x minus a into q of x. That is here if we divide p of x by x minus a, then if quotient is q of x, so we can say this, because if x minus is a factor, then remainder is 0. So p of x is equal to x minus a into q of x. Now putting x equal to a, we get it becomes p of a. P of a is equal to a minus a, that is it becomes 0, and it is q of a. So finally it becomes 0. So these two formulas are very important. Basic things is if p of a is equal to 0, then x minus is a factor of p of x. This is the gist of this theorem. And this is converse of that, that is, if x minus is a factor, then p of a is equal to 0. My dear students, at my next lecture on this chapter, we will solve some problems from your exercise. So today just you write down your homework. Your homework is, it is example number 8, page number 47. Given that the remainder of p of x is equal to 5x cube plus 6x square minus x plus 6 upon division by x minus 2 is 6. That is, if the polynomial p of x is divided by x minus 2, then remainder is given 6. Then find the value of a. So please solve this problem and submit this after this long vacation. Okay. Thank you very much. Stay at home and be well, be safe, and thank you very much for watching this video.